video is on topic number 2, multiplying and dividing rational expression. So like I said before, the multiplying operations or doing anything with rational expressions is similar to what you would do with fractions. Um, so the process of simplifying rational expression is like multiplying fractions. So just to remind you of how you multiply fractions, if you have two fractions here, you can fill in number you want for a and b, but this is like a over b times c over d. To multiply those two fractions, you just multiply the numerators a times c, and you multiply the denominators b times d. So if you want to look at a numerical example here, we have 3 and 3/5 times negative 2/9. The example here is doing it a little bit different, so I'll just do it the way that people normally do it on the side here. So we have 3/5 times negative 2/9. So you can just, when you multiply fractions, just multiply numerator times numerator. So you have 3 times negative 2 over 5 times 9. And then you get negative 6 over 45. And then you want to look to simplify this. So I want to think of two numbers that divides both negative 6 and 45. And that number is 3. Because 3 is a common divisor of negative 6 and 45, or a common factor. So divide by 3. And then you get negative 2, and 45 divided by 3 is 9. So the simplified form, the product of 3/5 times negative 2/9 is negative 6 over 45, which can be simplified to negative 2/9. Okay, so for simplifying rational expression, there are 3 main steps. The first thing is you want to factor the numerator if it applies. So there are going to be 2 different methods you're going to be using for factoring. The first one's factoring out the greatest common factor, which is like this one, when we are identifying what the greatest common factor of these 2's are. And then 2, there's factoring using the box method. So a little comment about factoring using the box method. You may have learned other methods for factoring, so you could definitely use that if you find it easier. Step 2 is to also factor the denominator, and then step 3 is canceling out the common factor in the numerator and denominator. Okay, so let's take a look at the first example. So the first example is specifically on simplifying with factoring out the GCF. So this is the rational expression, and so the very first step is I want to factor the numerator. So I want to take a look at the numerator here, which is 4x squared minus 4x, and I'm going to pay attention to what the common factors are here. So another way of thinking about common factors, like I want to think about what is the largest number I can divide out of the number parts and also the variable parts. So if I'm looking at just the 4 here, the largest number I can think of that divides both 4 and 4 is itself 4. So what I can do is I'm going to factor out a 4, and then I'm looking at the variable part. So this has x squared and this has x. So the greatest common factor or greatest common divisor here is x. So I'm going to rewrite this as 4x. So this is called the greatest common factor. Both terms have a common factor of 4, and both terms have a common factor of x. So this is greatest common factor. After you take out the greatest common factor, then you want to think about, well, 4x times what will give me x? Well, 4x times x is going to give me the 4x squared. And then 4x times 1 gives us times negative 1 gives us the negative 4x. So it's just a quick check of how this process works. I'm just going to distribute. So 4x times x is 4x squared, and 4x times negative 1 gives me negative 4x. So this is the factored form of the numerator. And I'm going to repeat the same thing to the denominator. So 6x minus 20. And again, we'll look at the number parts, 6 and 20, and try to think of the largest number that divides both 6 and 20. So 6 and 20 are even. I think of 2 first off and see if there's any other number larger than 2 that divides both 6 and 20. And I can't think of any other one. Therefore, the greatest common factor of 6 and 20 is 2. And then I'm looking at the variable part. So the first term has x. This one doesn't have a variable part, so it doesn't have a greatest common factor for the variable part. Therefore, this greatest common factor is just 2. So now I need to think of 2 times what gives me 6x, that's going to be 3x. And then 2 times what gives me negative 20, that gives me negative 10. Another way to think about getting these values is just dividing both of these by 2. So 6x divided by 2 is going to be 3x. And then negative 20 divided by 2 is going to give me negative 10. So you can think in terms of division, or you can think of in terms of multiplication. So that's step 1. Step 2, I factored, and now I want to write each of those results on top of each other. So 4x minus times x minus 1 divided by 2 times 3x minus 10. And now here's the part where you cancel out. So I'm going to look from numerator and denominator and try to reduce as much as possible. So I see 4 divided by 2 here, so that can be divided into 2. And then x, there's no x in the denominator, so that x has to stick around. And then I see a factor of x minus 1 and factor of 3x minus 10. Those two aren't the same, so they have to stay where they are. So it'll be x minus 1 over 3x minus 10. So therefore, the simplification of this original expression is this. On to example number 2. And so example 2 is just more advanced than the previous one, just in terms of the factoring of the numerators and the denominators. So these all require the box. So it just takes a lot more time to factor, and that's what makes this problem a little more, not necessarily complicated, but more time consuming than the previous one. Okay, so we just have to take it step by step. So we have the numerator 2x squared plus 7x minus 15. So I'm just going to do the box for these, and I'm just going to do them out so you guys can just follow the steps here and just make sure that I'm doing it correctly. So 2x squared, negative 15. My a is 2, my c is negative 15. That multiplies to give you negative 30. And I want the two numbers I need to find to add to give me 7. So the two numbers, let's see, we have 1 and 30, 2 and 15. We have 3 and 10. So 3 and 10 looks like those are the one I want. So if I want to be positive 7, this 10 has to be positive, this 3 has to be negative. So I have negative 3x and 10x. I'm going to do the common factor of each row and each column. So it'll be x, this would be positive 5. In this direction, that will be 2x. In this direction, it'll be negative 3. So my numerator factors into 2x minus 3 times x plus 5. Okay, I'm going to repeat it for the denominator. And as I'm factoring, I'm just looking at each term of the expression, see if there's any common divisor. 4, 8, and 3 don't have a common divisor other than 1, so I can just go straight into using the box. So my first term is 4x squared, last term is 3. My a and c are 4 and 3, that gives me 12. And then I want them to add to give me negative 8. So what are those two numbers? 1 and 12. Oh, 2 and 6 of those ones. They have to be both negative. I want them to add to give me negative 8. So I have negative 2x and negative 6x. And then common factor. So the common factor here is 2x. Common factor here is just x. Common factor here is negative, nope, not negative, just 2x, and then here is going to be negative 3. Okay, so the denominator factors into Ooh, this is weird. This should be 1. Positive 1. So I have 2x minus 3 times 2x plus 1. So that's the denominator. And then, so that's this denominator. And now, I should have color coded this better, but let's see, this is the red one. Okay, and then I need to factor the numerator here, the 2x squared plus x minus 1. So that's 2x squared negative 1. A and C is 2 times negative 1. And it's going to give me negative 2. And I want them to add to give me 1. So that has to be 2 and 1, 2 being positive, 1 being negative. So I have 2x, and I have negative 1x. Okay, common factor here is 2x, common factor here is negative 1, common factor here is just x, common factor here is just 1. So the factor form of the numerator is going to be x plus 1 times 2x minus 1. Okay, and then now for this denominator, I'm just going to use a shortcut since this coefficient here is 1. So I need to find two numbers that multiply to give me 5, but add to give me 6, and those numbers are 1 and 5. So I'm just going to add them up and put pluses there. Okay, so now step 2, I'm going to just do it on top of this one. So divide common factors. So I look at the numerator and denominator, and I just want to cancel them out in pairs. So I see a 2x minus 3 here, 2x minus 3 here. So I cancel them out. I see an x plus 5 in the numerator here, and x plus 5 here, so I can cancel those out. Okay, and then I have a 2x minus 1 here, and this 2x plus 1. So I'm just going to quickly check if that's a mistake or not. Yep, and there's a mistake here. This should be a negative 1. Okay, so then that makes this negative. Okay, so now I can cancel out those out in pairs. So that'd be 2x minus 1, cancel out. Oh, and then it looks like everything cancels out actually. Okay, so since everything cancels out, you have, when everything cancels out, you just have one in the numerator and one in the denominator, so you just get 1. So the simplified form for this is 1. So this is a pretty atypical one. Usually the examples are made so that you have some factors left, but that's okay here since they all cancel out.